Hello, I am Kishore Kumar, and today I am going to talk to you about the Espressif ESP8266 module. This is not just about ESP8266 module. Here comes the development board. This in general we'll call it as a node MCU, but this is not exactly node MCU because the ESP8266 these modules and node MCU everything is an open source. So the Gerber files everything is available in internet. Anyone can download and design a PCB and they can develop a development board like this. So someone have downloaded, designed it and sold it online. I have purchased it through it. So here the chip is ESP826612E module. This is SoC module. Inside the module there will be a chip, Espressif chip, IoT devices which you are using in day-to-day life, developed by a big company or a small company. Everyone are using the Espressif company chips. In this module, here is the SoC module, and this is Wi-Fi antenna. Here is a voltage regulator AIMS777, which is used to regulate the USB 5 volt into 3.3 volt to power up this module. Here is CH340 USB to TTL converter, which is used to communicate with the USB port and this chip. The advantage of this chip is other microcontrollers we need to use a programmer. For example, microchip companies, Atmel, every chip manufacturers, they will give you a like JTAG, PIC3, PIC2, etc. programmers. But in this device, the advantage is there is inbuilt programmer. So just we need to use a TTL converter and you can program the chip. The chip comes with a bootloader. You can program this chip using in two ways. One is the Arduino IDE, another one is MicroPython. So I recommend you to use this with Arduino IDE because due to low memory and everything. Let me explain you about the pin details of this chip. Let's now check the pin diagram for this thing, for this development board. Here they have mentioned it D0, D1, D2, D3, D4, 3 volt ground, everything. I'll show you in the picture. The first one is D0. Actually, for our simple conversions, they use D0, D1. It's GPIO16, GPIO5, GPIO4. In Arduino code, we'll use this D0, D1 for declaring input and output functions. The D0 to D8, these are all digital pins, that is digital inputs or outputs you can use. Here comes an SPI interface, MOSI, MISO, SCLK. These pins are SPI interface, serial peripheral interface. Also the D7 and D8, that is GPIO 13 and 15 can be used as a secondary, that is like a software serial ports. So we can use these pins for serial communication also. The actual serial communication is GPIO1 and GPIO3. Actually we can't use this 1 and 3 for any other digital IO purposes, only used for UART communication. And here the secondary SPI pins, these pins we can't use for any purpose because it's directly connected to internal ESP8266 module for internal programming purposes. And GPIO9 and GPIO10, these also we can't use. Enable and reset pin, it can be used. And here comes ADC0. This is the only one analog pin which this ESP8266, that is ESP12E module contains. So here in the module itself contain a LED. This is connected to D4, that is GPIO2. This is directly connected to the LED. Now let's check the wiring. Just we can blink an LED using this. Here we can use a breadboard. So now I am using inbuilt LED, that is D4, to blink. Okay. So now I will connect this to USB. Okay. Now let me check. This is Arduino IDE, and here we selected Node MCU 12E. In tools, first of all we need to select COM4. This is Arduino IDE version 2.0, so it comes it's advanced version of that previous IDEs. So here we need to select this as ESP8266. So whatever module comes with ESP. Here, this is the board which we are using, ESP8266, that is ESP12E module, and it is connected to serial port USB. Here it is mentioned as USB. We previously installed the drivers for CH340, which we can check here. Manage device manager, scene ports, USB serial port, it's COM port. So the serial port driver is installed, so that's why it is detected here. Here we are receiving COM4 and we selected the board, so according to this the libraries and everything will be loaded. So here we can give a simple program. So now we need to make digital pin, that is D4 pin, inbuilt LED to blink. So we need to declare the pin, whether it is input or output. So now I will declare the pin mode D4 as input. You all should notice the programs are case sensitive, so PIN and M is caps, pin mode. D4 and input should be in caps. Okay, this is the setup program. The setup program runs only once, and this is the loop which runs continuously. So here what I need to do is, here the pin D4 is declared as output. It is an output. I made a mistake. Output. Okay. Now what I need to do is, I need to tell that D4 pin. No, I need to give for better understanding, I need to send voltage to the pin D4. How I will send the voltage? Digital, right, once more you check, I am using WS caps, digital write. D4 in digital, there is only two zeros and ones. You need to mention either high or low. You don't care about the voltage, whether it is 3 volt, 1 volt, 2 volt or 5 volt, anything. If it is 0, the pin's voltage will be 0 volt or less than 1 volt. It's according to the microcontroller's design. So here we need to make it high. Okay, So now the voltage will be high in D4 pin number D4. Then how it will blink? So here we need to bring down the pin low. Digital right, D4 low. So now the pin will be on and the pin will be off. Here there is a mistake. How I will tell for how much seconds or how much minutes it should be high and how much minutes it should be low? Because it is blinking. These devices run at inbuilt frequency is 80 megahertz. So 80 megahertz means you can understand it will be in it will be running in microseconds. So what I should do is I need to give a delay. So I am telling the microcontroller to wait for some around 500 milliseconds, so that the controller will high for 500 milliseconds and then it will be low for 500 milliseconds. So what I will do is now I will download the program. Now the program is downloading. At the time this indicates the program right inside the flash memory. So 100% completed. Now you check, it's blinking. It's on for 500 milliseconds and off for 500 milliseconds. So now let's change the time from 500 to 200. What happens? 200. Now I am changing it for 200. Actually, Arduino is an IDE. They are not microcontroller manufacturers. They are giving a software to develop a program. Now you can see it's blinking fast because we just gave only 200 milliseconds. Now we can reduce it to say around let's see 50, so it will go very fast. 50. See, now it's blinking very fast. So that's it. This is a simple programming. Actually this is an old stuff. Everyone can if you open YouTube you can see the LED blinking. This is a very first program. Whichever microcontroller we are selecting, or if you are new to this embedded field, if you are entering, first everyone will try the LED blinking. So now we have connected the inbuilt LED. Now we want to connect the for example we'll choose D2 to blink an LED. So what I will do is, this is an LED, green color LED we are having. The lengthy pin is plus and the short pin is minus. So what I will do is, this is the ground, so I will connect ground to now we have selected there. D2. Okay, we can give directly to the LED, or we can use a resistor. Say I am using 150 ohm resistor just to okay, this glows because of the induction. So now actually you see D2, I am connected to D2. Now I am connecting it to D4. What happens? You can see actually now the D4, the voltage is high. So now I am connecting it to D2, and what I will do is I will just change these to D2, here D2, here D2. Now I am writing the program. See now the onboard LED is blinking. This LED is blinking. Let's now try some fancy things. Again here D2 pin mode, D4 output here, D4, this to D4, and we can change it to 100 milliseconds. 100. Okay, so now we are downloading it. Now what happens? While D2 is high, the D4 will be low, and when the D2 is low, D4 will be high. So you can't recognize this because this is 2 speed. So I am changing this time to 500 millisecond. Yeah, here comes a problem. Actually both are glowing at same time. Why? Because D4, the onboard LED is connected to logic low level. Means I will explain in some other video. Actually if we drive 0 to the D4, the LED will be glow. If we drive 1, the LED will be off. Why? Because now I have here I connected ground, and I am giving positive to from pin number D2, but in D4 it will be opposite. The positive will be permanently connected to 3.3 voltage, and the negative is driven through the D4 pin. So now what I will do is, here I will change high, and here I will change low. Yeah, now you can notice this is the simple program. So I am explaining you, this is not to train you to glow an LED, this is a logic. So if you are new to this devices, you just first check with this. Step by step we can go into the logics. the simple to complex logics. Okay. Now if you have any queries, you can leave it in comment boxes. Also, this is not just a training videos and all. I am starting a forum for this ESP8266, not only ESP8266 modules, also I will come with ESP32 module. This is Arduino Nano. Now we are going to do automation works using these modules. So from basic, starting from home automation to industrial automation. Nowadays Arduino is supporting for industrial automations also. Arduino is just a IDE platform, so you can code using C++. Actually microcontrollers we need to code it with C. Previous days and all we'll program it with an assembly language. After that we programmed it using C. And now using Arduino platform or VS Code Visual Studio Code platform, we are programming the microcontrollers using C++. Also you can code using Python. Not every controller support Python, MicroPython. These Espressif companies means the ESP8266 modules, ESP32 modules, these are all supports. This ESP32 module have inbuilt Bluetooth and Wi-Fi. This comes only with Wi-Fi. So in the next videos we are going to see about the automation, means how we can automate our own house. The next thing, how we can automate our surroundings and everything, because future we are not going to import anything or buy anything from internet or foreign countries. Just we need to develop our own products. So this is an initiative. You can join my community to develop further products, and I also support for designing PCBs and developing softwares in C# as well as web applications. Everything is open source.